This is one of a very interesting lectures which teaches us about function pointers, and it's very important to understand this because it opens the gateway for callback functions. So here we learn about type def, function pointers, and how to use them. What we do is that, let's say we have a scenario where we can call a function and which has the same declaration, that it returns the same variable type, it takes the same arguments and same number of arguments and same type of arguments. Then in that case we can make a function pointer that can point to all such functions, and whenever we are trying to pass, so we'll just make the function pointer equal to whatever function we like to call, and then we will call that function. So this saves a lot of coding space, and let's see with this example. So we try to see this code. So what happens, we have four functions: float, plus, float a, float b. It returns a plus b. So I pass two arguments in float a and float b, and it returns the sum as a float, then minus, which returns a minus b, which is again a float, multiply multiplies those two numbers, and divide, which divides those two numbers. So what happens now is, so, and we define float bracket star fptr float. So this is a kind of defining the function pointer. So now fptr is a pointer to a function which takes two arguments, both of them as float type, and which returns a float type. So this fptr can be pointer to all these functions as they take float a and float b. All of them take two floats as argument and returns a float. So now what happens is that, and here again I define a different function pointer directly, not using any type def. So ptr2 function is a pointer to function of type which takes two floats as argument and returns a float. So I make it fptr, I define a new function pointer and make it equal to null. So here I use the standard definition, here I use the type def definition. So now pointer to function, so plus is one of such functions, and I make pointer to function point to this one. So now this function pointer is pointing to a function plus. So I say print a plus b, I call this pointer to function, I pass those two arguments. Now this function can act as all of the others, like plus, minus, multiply, divide, and any such function which take two floats and returns a float. So now I've passed this pointer to function with two arguments a and b, and it will now do the operation based on whatever function I assign that function pointer to. So this does the plus for me. If it is minus, I assign it to minus function. Now I call pointer to function with ab, so it returns me the difference between them. Now I make fp a function pointer equal to multiply, I plus fb with a and b, and it returns me the product. And finally fp, I make it equal to the memory location of divide function, and it, when I pass it, so it prints the division of these two. So let's run it. So now we see a is 6, b is 2, and we see pointer to function, it's float type, it's returning, and float arguments it's taking. So pointer to function is fp is also null, both are null now. So now what happens is that after this, so pointer to function, so what happened is that now let's see the output. So a plus b is 8, so after calling the first one it returns the addition of them. Next, pointer to function now is minus, so which is shown here. Now what happens is that when let's go inside this function, so it goes into minus and comes back, so it prints the difference between them, which is 4, and then I make fp is equal to multiply, call the function fp, and now I see, so the multiplication is 12. I call the function again with divide function, and it prints for me 3. So this is the use of function pointer. It's also called the callback function, and it's quite useful and handy in many of the kernel programming and callback functions where we don't know which function we are going to use, so we pass the function pointer is passed in as an argument to the function itself, and then we pass which type it is. So this is a very good example we saw. So we will just try to